Right, we're looking at the C1 paper, Edexcel, May 2015. Some helpful hints, not necessarily answers, just some helpful hints. Right, first question, part A. So I need to turn the pen on. There we go. We got 2 to the power, 2 to the power, 2 root 5. So I always split it up and put the root bits next to each other because we get 2 times 2 is 4, root 5 times root 5 is 5, so you should end up a pretty easy answer. The second one, we got root 2 over 2 root 5 minus 3 root 2. We got to rationalise the denominator, so you multiply by a special 1, or Jose Mourinho, as I like to call him. Right, although he's not so special since he got binned off by Chelsea, but there you go. There we go, and multiply out. Most of the roots will disappear and you'll be able to leave it in the form that they asked for, which is a plus b, where a and b are integers. Question 2, we need to quickly rearrange this first one. So y equals 2x plus 4, and then I'm going to substitute in y equals 2x plus 4. 2x plus 4 squared plus 20. So all I've done is swap the y in the second equation for 2x plus 4. Multiply out, factorise. Don't forget to calculate the y coordinates as well as the x coordinates, because you're factorising will just give you the x coordinates. Okay, question 3. Now, before we start, I'm going to not change the equation, but I'm just going to rewrite it. First bit's not going to change, the second bit will. So that's 5x to the minus 2, and then I can differentiate that. I'm going to actually do this because there's common mistakes that people make. That one, pretty straightforward. Minus 2 times minus 5 is plus 10 to the power minus 3. And when I integrate this, I'm just going to rewrite it in the standard form. So we should have that, shouldn't we? Right, so I'm going to quickly up the power, and before you shout at the screen, I know that I haven't finished. Up the power, simplify that, don't forget the plus c, that would be a silly mark to lose, wouldn't it? Question 4, we have arithmetic, we've got a series here, so let's have a look. It says, to get un plus 2, I need to add 2 lots of un plus 1 minus a un. So I need to do 2 lots of un plus 1, there you go. 2 lots of 4 minus that one, 4, which is 4. Oh, hang on, everything appears to be 4. So therefore, if I'm asked to sum the first 20 terms of this, it's just 20 times 4. I'm sure you can manage that. Now V3 down here, if I'm looking here, right, it's 2 lots of Vn plus 1, well that's 2k, so 2 lots of 2k minus k, which gives me 3k. Now, I don't know about you, but I'm sort of spotting a pattern there as well. So 2 lots of 3k, 2 lots of 3k minus 2k gives me 4k, so first term was k, second term was 2k, third term was 3k, fourth term was 4k. I need to sum the first 5 terms, and I'm told that the answer is 165. So therefore it's just k plus 2k plus 3k plus 4k plus 5k equals 165. That's a nice simple equation that you can now solve. Right, okay, now in order to have no real roots, we've got to, for part A, find out whether b squared minus 4ac is less than 0, because you can't square root a negative, at least not yet, you can't anyway. So if a equals p minus 1, b equals 4, and c equals p minus 5, okay, throw that into this formula here, the b squared minus 4ac, and rearrange it, and that is the answer you're looking for. Now for part B, we're going to use that answer here, plus 1 is greater than 0. I'm going to solve that by completing the square. Don't forget to take away the square of this bit. Alright, minus 9 plus 1 is greater than 0. We'll end up with a quadratic. You'll be able to, sorry, not a quadratic, you can solve by completing the square. You should end up with, and I'm going to give you the answers, this. It's easy to make mistakes on this, so take care when you're doing it. Alright, but these are the two answers. Okay, so number 6. I can't do anything with that at the moment, differential wise, until I multiply out the top brackets plus 4x minus 12 all over 2x. I still have some simplifying to do. That's going to become, x, oh, I need to rub that out, that's rubbish, x squared over 2 minus 3x over 2 plus 2 minus 12x to the power minus 1. Now I can differentiate that. Alright, should be fairly straightforward. I end up with x minus 3 over 2. The 2 disappears and it becomes plus, oh, I don't know where I've been really silly here. That should be a 6, shouldn't it? 6x to the minus 1, not 12x to the minus 1, plus 6x to the minus 2. Oh, God, what is wrong with me? Jeepers. Can't write all of a sudden. Right, x to the minus 2. Now, that's part A done. Part B, okay, I need to put x equals minus 1 into y and into do I dx. Alright, so I think when you put it into y you get 10, is it? 10, yeah. Alright, when you put it into do I dx, you should get 7 over 2. Right, you then use y minus y1 equals mx minus x1. Alright, and rearrange, multiply out, rearrange, all that sort of stuff. Okay, now hopefully if y equals 2 to the power x, 4 to the power x is 2 to the power x squared, so therefore 4 to the power x is y squared. Alright, and then we're going to insert those into, for part B, we're going to say that 4 to the power x is y squared, and 2 to the power x is y, and we're going to get that. Alright, should be able to factorise fairly easily. I will do that. Okay, it will work fairly nicely. So you get your y equals 1/8 and 1. You've got to remember that's 2 to the x as well, because y is 2 to the x, and what power of x? What power of 2 makes an eighth, and what power of 2 makes 1? Okay, next one. Here we go. Question 8. We're going to factorise completely. So we get x. I'm going to take out an x, and we get, where are we, 9. Oh, oops, I'm doing it up here because I'm going to need 9 minus 4x squared. Alright, now that, hopefully you've noticed, is difference 2 squares, 2x and 3 plus 2x. Because I need them, because these are the places where the curve cuts the x-axis. So my curve is going to go, because it's minus x cubed, it's going to come down here, up here and down there. It's going to cut at well, x0. 3 minus 2x is going to be your 3 over 2 here, or 1.5, and that's going to be minus 3 over 2. Alright, pretty straightforward again. Now, in order to, so that was part B, part C. In order to find a different distance, of between those 2 points, where A and B lie on C, you've got to show the length AB is k root 10. Now, A is minus 2 something, and B is 1 something. Just put those, substitute those values into this here, where is it, there, okay, and we should get 14 and 5. You then use a bit of Pythagoras, difference in the x's, difference in the y's, and then you should be able to simplify that surd accordingly. Right, we have an arithmetic series here for part A. Starts on 17,000, and this is all from the formula that's in your formula book. Right, times 1,500 is how much her wage goes up each time, and it equals 32,000. Alright, solve that equation. I'm going to have to use it, so k equals 11. Alright, but work it through. Should be fairly straightforward now. For S20, the first 11 years her pay's going up, so we need to use the formula from our formula book. Alright, and we get 17,000 there plus 11 minus 1 times 1,500. But then I've got to add on the other 9 years when she earns 32,000. Right, put that in your calculator and you should be fine. There you go. Okay, right. Number 10, I think this is the final question if my memory serves me correctly. We've got to do this. So it says find f of x, y. Before I do anything, I'm going to call f dashed of x, I'm going to rewrite it as 3 over 2 x to the power of half minus 9 over 4 x to the power minus a half plus 2. Right, I'm then going to integrate, and I'm going to get this, which is x to the power 3 over 2. X to the power 3, I could put f of x, couldn't I? F of x equals, alright, x to the power 3 over 2, and then it's going to be minus 9 over 2, x to the power half, and then it's going to be plus 2, x plus c. Now we're told that 4, 9 is on there, so you swap. So you're going to make it 9 equals, where are we? 4 to the power 3 over 2 minus 9 over 2 times 4 to the power half plus 2 times 4 plus c. C you find equals 2. Alright, and then for part B, so that was part A. Part B, if the equation of the normal, right, the gradient of the normal, is minus a half from rearranging that. So therefore, the gradient of the tangent equals 2. Alright, because you know the gradient tangent normal multiply to make minus 1 or negative 1. You then make your gradient function equal to 2, solve it, and you get your x coordinate, which is 1.5 or 3 over 2, whichever you want to call it.